We just learned the quotient rule. Let's see some examples. Let's start with the one that I showed you guys at the beginning of the section. F of x equals the natural log of x divided by x squared plus 1. Okay, so we have a high, we have a low. Let's follow the pattern. Here it is. Let's break it down. So our derivative f prime of x equals, we begin with low, just copying the x squared plus 1, times d high. So the derivative of the high, we know that's 1 over x, minus the high, natural log x, times d low. Well, d low here is 2x. And that all gets divided by the original denominator squared. So x squared plus 1 quantity squared. And there's our derivative. Okay. Now, one thing I want to point out here, this could be simplified, and we're going to do that in just a moment. However, when it comes to your test, or this would apply to quizzes as well, when it comes to a test or a quiz, if all I'm asking you to do is take a derivative with these now more complex rules, then part of those directions are going to be you don't need to simplify. Okay, so if I was to ask this question on a test, find the derivative of this function, and you did this, that's all I want to see. So you would circle that. That's how you would answer a test or a quiz. If all you're being asked to do is find a derivative, you don't need to simplify. Why would I say that? Usually we simplify everything in math. And yeah, certainly we do. And we're going to have to simplify derivatives, as we learn more. But for the time being, I really just, if all I'm asking you to do is take a derivative, then I'm testing you on, do you know the derivative formula? Do you know the quotient rule? Do you know the product rule? And I don't want you to lose points because the simplification is difficult. If all I'm doing is testing you on performing the derivative only. We're going to have plenty of opportunities to simplify these derivatives. Trust me. So when we're first learning them, I just want to know, do you know how to take the derivative in the first place without having to worry about, have you simplified it correctly? Okay, but just for the sake of our lecture here, and for the practice, let's go ahead and simplify this as well, although you would not have to do that on a test. Okay, so what you would do, and this is not obvious. Okay, let me just cover. Let me get rid of this just for the moment, so you can follow with me. So I decided to go ahead and multiply out the 1 over x. So that makes sense, right? Distribute it here, and it would just be x. Distribute it to the 1, and you'd have 1 over x. This part on this side looks a little bit awkward. Let's write the 2x in the first position. I mean, that's really not anything, but it looks a little bit more natural this way. Minus 2x natural log x is how we typically write that. And the denominator did not change. When it comes to quotient rules, don't expand that. Don't multiply that out. We like it just like this. It's nice and compact. X squared plus 1 quantity squared. Just leave it. Okay, but we can still simplify. Why can we simplify? Because we have this fraction right here, 1 over x. We have a fraction inside of a bigger fraction. And that's not in simplest form. You're like, oh, well, what are we going to do? We've got a fraction inside of a bigger fraction. How are we going to clean that up? Okay, it's actually very simple if you know what to do, but it's not obvious. We're going to multiply the top and the bottom by the same thing. Well, if we have 1 over x here, why don't we multiply the top and the bottom by x? And that doesn't change, right, the value of the function, but it's going to get rid of this fraction here. So what would that look like? So the x here, well, it would distribute to all three. So x times x times 1 over x gets you back to plus 1. And x times 2x natural log x would be 2x squared natural log x. And then in the denominator, well, x times this, we're not going to multiply it all out. We're just going to put the x in front, like so. And there is the simplified version, just for our practice for the time being. Okay, very nice. Let's try another one. Okay, this will be a challenging example. This will be good. How about y equals 5x squared e to the x over x to the fourth minus 6? Okay, why is this challenging? How is this different from the last example? Well, clearly we have a quotient, right? Numerator and denominator. But look closely at the numerator. What's going on there? Isn't that numerator a product? 5x squared times e to the x? Oh, wow. Okay. So how is this going to play out? We'll use the quotient rule, of course. But in the midst of the quotient rule, we're going to need to use the product rule. Why is that? Well, the quotient rule, remember how it goes? It's going to be the low, but then it's going to be the derivative of the high. Well, in order to take the derivative of the high, we have to think of it like a product and use the product rule. And then, we'll keep going through the rest of the quotient rule. Okay, let's see it. We'll talk through this a little bit at a time. There's a lot here, but we just go through it one step at a time. This is also a reason why, if I'm testing you on just taking a derivative, why I would not want you to simplify as well, just because that it's enough of a problem in this case, certainly, just to take the derivative. That's for sure. Okay, so let's go for it. So it's y prime equals, now the quotient rule says low, so we take that low, but we're going to multiply that by the derivative of the high, and that's what we see here. That whole thing is the derivative of the high. Let's talk about that. Why is that the derivative of the high? Okay, so our high is 5x squared e to the x. So derivative needs product rule. So we've got first and second. Derivative first, 10x, times the second left alone, plus the first one left alone, times the derivative of the second, which in this case happens to be itself e to the x. Okay, so we have low d high minus, and we keep going with the quotient rule, high, just the original 5x squared e to the x, times, and now it's d low. Well, what's the derivative of the low? 4x to the third. Okay, so again, low d high minus high d low, and it's all over that original low squared. So this is how you would answer a test or a quiz if the only thing you're asked to do is find a derivative. And that's a lot, definitely. I didn't write it on my notes, but there is a strategy some students like. Okay, so some students, they like to say, okay, they kind of like to break it down more instead of just going for that derivative all in one shot. Like, can we break this down? So if I kind of think of this problem again, right, they'll say like, high equals 5x squared e to the x. And then they'll take d high. They'll get ready for it. And then over here they'll say like low equals x to the fourth minus 6. And then they'll say d low. And they'll go, okay, so what's this derivative? Oh, it's a product. We're multiplying there, first and second. So 10x times e to the x plus 5x squared, and derivative is e to the x. Okay, perfect. And then over here, d low, 4x to the third. And then they'll just piece it all together to create that. So they would say, okay, it's low times d high minus high times d low, and then all over the low squared. And so highly encourage, break it down. You could do this with product rule. I mean, easily, right? Write it out, write like first equal first, second, and then derivative first, d first equals what? D second equals whatever, and then fit it together in the formula. I mean, that's awesome. If that's helpful, then I think that's really, really good. Okay. So we've said, hey, there's our answer if we were taking a test. But just for the practice, let's simplify this because we are going to have to simplify these things. Even in these sections, sometimes we have to simplify these if we need more than just a derivative. If we need like the slope of a tangent line or something like that. Okay, let's go for it. How would you go about simplifying? Well, no easy way around it here. We're just going to multiply out this numerator, try and combine any like terms. So let's see. X to the fourth times 10x e to the x, well, that'd be 10x to the fifth e to the x. X to the fourth times 5x squared e to the x, well, that's 5x to the sixth e to the x. Negative 6 times that first one. Negative 6 times 5x squared e to the x minus 30x squared e to the x. Okay, and then multiplying these, well, let's see, 5 times 4 and x to the x squared times x to the third and e to the x right there. Okay. And then it's still all over. Again, don't multiply that out. Just leave it as x to the fourth minus 6 quantity squared. And then from there, there's just a little bit left you can do. We notice that's an x to the fifth e to the x, and so is this. None of the other ones are going to combine, and so in this case, our final answer is here. Usually you put the highest power of x first, so 5x to the sixth e to the x. 10 minus 20 is going to be minus 10 x to the fifth e to the x. Then we'll go with the minus 30x squared e to the x, and finally the minus 60x e to the x all over that same denominator. So here's our simplified version. Okay. That is a beast. Let's go to the next example. You know what? Let's stop here. I think we've done enough for one video. More to come.